Thank you for joining me today. Those who are here, I will record the session just in case anybody needs to check something later. Welcome to this final part of the course. We've been through all the materials. Everything's been said and done. So I'm basically telling you today, I'm leaving it all to you. And we will not need to spend an hour or so like we did before, but I'll just let me just switch this bell. Don't make a sound every time somebody. Right, so I will just say a few things of what I think you could do in this final project, which of course means there's no exam or any other formal assessment. And in programming, of course, we would like to have, as a result of a course, a running program rather than answers to test questions. So let me see if that works. I have uploaded something to the Moodle page. And the idea is, of course, you do something where you can apply everything or anything that has been said or introduced before. So I'm assuming that if you have access to those materials and you've basically understood what it's about, you will have no problem at all taking some of this code or some of the things that you have learned along the way and get a final project done. And of course, we're not so much worried about basic Python now anymore. We're in the intermediate section already. So if you have a data set, you can do data handling, supervised and unsupervised machine learning. Not necessarily in that order, but we'll get to this. So the instructions there, you have to read it for yourself quietly. I will not go into all of this, just tell you that there are, as usual, there are some links and it might be good to download some things and have a look there. So what's there? So the data folders, of course, that if you like to just start with some data set, you can download it here as usual. There's a zipped folder, unzip the folder, put it in the same folder as the notebook, and then it's called data, and then everything is there, and you just import from there whatever you need there. And then there's some instructions I'll show you in a second. And then there's a model solution. So I have sort of worked out things on using one of the data sets. So I import it, do some analytics, and then supervised and some unsupervised machine learning, and repeat the whole thing with the PCA reduced data. So that's it. So you can have a look there if you need some inspiration. And in general, I would say, I think it mentioned somewhere, but keep that in mind. If you have some idea about what you would like to do with those data in this broader context, of course, please go ahead and just try that. Right? One of the data set doesn't have labels, so maybe you don't want to do supervised machine learning with it. You can put some labels or you do something instead. But if you have an idea of something that can be done, try it. And if it doesn't work, come back to me or to one of our tutors. I'll send it around and we can still do it. So the model solution maybe is the way to start. Look at this and you will see what it is. It's just what the instructions say. Just do something along. There's also a PDF that doesn't work that you can download and have with you. And it also mentions that data science project or a machine learning project is not an essay. So don't worry about a lot of sentences or something, or reporting or discussing things. you can do that in your paper that you will write next month. Then you can discuss everything that you want, but here you just do the code. And I said, as a rule of thumb, if for every figure, every result that you produce, every number that you create, if you say a sentence, that's more than enough. If you don't say anything, it's a bit weird. It will still be fine, of course, but it's sort of nice as a notebook if you have a conclusion sentence. Like I give you the example in that model notebook. If you look at it, I do unsupervised clustering, and then I conclude the clustering doesn't work, period. Right? So not much of a, because that needs, of course, investigation why it doesn't work and so, but that's not the point here. The point is whether you can do it or not. And I think that's all that I have to say. So here's what you should do. You bring in your data, handle them somehow, analyze, look at the data set, analyze what's there. Then you try dimensionality reduction. Then you do an unsupervised method, try a supervised method if you have labels. And you can repeat those with the original data, with the PCA reduced data. You can check whether normalization or scaling makes any difference to it. And that's about it. Well, actually, that's about it. It's actually a lot that you have done once you have that done. And I think if you get this done, this is really a big step from basic Python to get to this point. And you know that if you have some idea, if you have read something about a new clustering method or some fancy technique, you can always look it up and see whether there's something in scikit-learn. If it's there in scikit-learn, just try to import it and try to use it, because many things are all along the same conventions in scikit-learn. So once you know one unsupervised method, another one might not be so difficult anymore. Of course, things can always go wrong, but then that's part of the game. And of course, we encourage making errors, because that's how you learn programming. I encourage you not to submit any errors as your final project, because what we want is something that you can then take and put on your web page or on your CV, link to it and say, this is what I've done, and you want to be proud of that. So if there are errors in it, we'll make sure we remove them, and if necessary, or any of us, me or the tutors or anyone, will be able to help you get rid of this. And remember, it's programming. Every problem can be solved. It's unlike real life. In programming, every problem can be solved. So submit this, and then that's it. And then you're done. And time-wise, the original idea from the course was that this substitutes 2 weeks lessons, but I don't really care too much about. You should feel what time you want to invest, also given the other restraints that you have. And as long as we get to a good product, that's it. If you're a very genius programmer and you need half an hour, then that's as well. If you need a long time, but you feel it's worth investing to struggle and learn all those things, then that's good as well. Okay, so that's it. I'll show you just what we have here. So if you look at maybe the important thing to do when you want to sort of get a feel of, you don't know which data set you want to do, I have given you for download, there's a notebook. It's called Data Checks. So that Data Checks has, for all of the data sets that are downloaded, an import test, so to speak, and data import, and a quick plot of some I don't know, some box plot or something. So that if you just go down through this, within a minute, you can have a look at all of the data sets that are there. So you just do, I don't know, does it work? So you export that function and it works, it just works. So the first one is the one where you have the model solution. So you can see what the data are, what the solution is that I think might be one way of addressing those things, and so you can follow those lines and deviate wherever you think you don't need it. And you just go down, you have a look, there's this breast cancer set. There's also a link to the original where it came from. And I think that UCI, that's University of California, Irvine, and they have also a paper with it. So if you want to dig deeper into it, you can do that. And then you have a couple of columns, and then you can see what's in there and so on. So that goes all the way down. Cervical cancer and the diabetes is from scikit-learn echocardiogram. So the most important thing then for everyone, and I want you to consider that, those that are not there, of course, I have no problem if you find a data set anywhere. If you take, like it says here, the imaging, we've introduced that Nibabel resource, which is a good resource. You have brain imaging data there. You can take, of course, data from there and try something very similar to what was done in the imaging section. Or anything else. You know, out there is proteomics data and metabolomics data and I don't know what, all sorts of things. If you find any of them more interesting, then maybe you want to just go ahead and do it, or you send me a link and ask me, what do I think of it? And we can have a look together and see whether that's suitable or not, what can be done. Right? So have a thought about it. If you can't be bothered to finding your own, that's fine. So that's why something is there. And if you run into problems, you tell me. But if you find something, then that may be more interesting because it's something along your lines of thought. And once we see a data set, there's always more things that we can find out, because if you have an interest or a background in that area, maybe you can bring in much more interesting aspects that I wouldn't see there. So of course, the major part of data science, one part is programming, but the other part is the expert knowledge, and this is what you have to bring. All right, so use data checks to have a quick overview of what's there, unless you, of course, have decided already then. And then the second thing is model project. That's what I said is the one that worked out with that first data set, where I have just put some functions and said that and how you read the data set. It doesn't do, I have to implement everything, and then it just reads that data set and does a lot of things with it. So there's some matrix and so on. Have a look at it if you want to see how you want to structure it, but it's the same thing. Import, get an overview, do an unsupervised method, do a supervised method, and try the same thing with the PCA reduced version of it. And this is just for you as a sort of background resource material. And if you want to use the project template, you can use it. There's a template for download. If you don't want to do it, you want to do your own way, please go ahead, do your own way. So I have just structured it with the table of contents, which is the project data handling first part, and dimensionality reduction, clustering, classification, just in that order. You want to do it, you can do it in this way, just to give it a bit of a structure. Okay, and was that? Yeah, well, that's just a template, so you can use it or not use it. And the final thing is, of course, any support. So I said between now and your submission, I've put an arbitrary deadline, which is the end of February. You submit when you submit. So if you want to get rid of it, submit tomorrow, that's fine. You need longer than 28th of February because you have to do this important other project. We can always work somehow around that as well. But I think the best is to do it as soon as possible, as long as those things are fresh, and not to leave it until, say, April or so, when you have probably forgotten a lot of it, and then it's more work to fresh up your brain. And what was I going to say? What I want is the final project to be without any errors, so have it in a way that we can sort of say, that's good. We will look at every submission, so every running code, and give you feedback on it such that you can be sure when you put that project up on your web page or show it to somebody else that there's no problems with it, that this is checked and consistent and good. And of course, that gets a pass. That is what you have done. It as long as there are problems, please come back and ask for help so that we can resolve all of those things. What will be me and the two tutors that you saw in the two previous sessions trying to help you, and there's a lot of other people somehow in the network that will be able to access, or will find other people if necessary, if it's more of a specialized topic. Of course, you are also welcome to discuss things among each other. So if you know each other, you can discuss among each other. You can ask anybody in the world, Google, whatever you need to do. And if you have access via your institution to experts, then of course you should also try to use that. So we're thinking not as a closed book exam where somehow you shouldn't look there, but all the world is open to you and you use it like for a good manuscript that you submit. Where everything that you check, that you get from others, if you take something from others, you acknowledge it. And if you can even invite other people to be project partners if you want, but still, of course, if you do it, then you will get the accreditation as usual. So I think we are nearly there. So what else? Criteria. So if we have something that we don't think is perfect, or contains things that where the code works but is somehow conceptually wrong or such, submit it. Then the tutors and I will try to give a feedback where we say, look, before we tell you that yes, it's a pass, we would like to see this and this done. So that will be only constructive feedback. So we will not criticize anything. We will say there's something missing. You will tell exactly what you need to do in order to get it sort of complete. So that we see there's no question about getting a pass. The only way to not get a pass for this project is if you don't do it. So if you do it, you will get, so that's what we want to do, right? You submit the running code, and if there's something wrong, we will suggest it. And if it's good, it's good. And if something is fundamentally missing, we'll tell you what it is that is missing and how it can be fixed, such that you are confident that you have passed the course, yes, but you are also confident that you can do those things, not necessarily like an experienced programmer after years of programming, but in a way that once you go step by step, you will be able to get to that result with a good understanding of the programming language, of the concepts behind analyzing and optimizing results, and with the possibility to write that down in a project. And yeah, have a look at those things. All of the things that you need to do in order to get a nice projects are, and I have tried that myself, are based on code which is in the lessons of the previous that we did together, right? So any of these things has not been done with me programming something, but just basically copying code that was there in one of the lessons and then just bringing in the new data set. So that's a tip. If from the outset you just call your data set data, then of course once it works, or you copy it from the lesson and you replace, when there's a funny name, you replace the data set with data, then whatever data set you have, you can just apply the same code without much extra work that needs to be done. And then you can see how well classification works or not. So, right. Questions you ask me now, or you send me an email. And of course, if there is something that maybe is not so easy to say, two things. If you have a problem with the code and you want to have some help, please always include the whole code that led to that error. Yeah, if you send me, I keep getting messages where somebody tells me I get this error and I don't see the code that led to it, or I see the last part of the code but not all the previous part. Of course, it means I cannot reproduce the error. And if I cannot reproduce the error, I cannot diagnose the problem. So always make a new notebook for each subsection. You can make a new notebook, just import the data set. And then if you send it to me, I will just be able to, or the tutor will be able to reproduce the error, and then we'll get to it. As we have done previously, then the second thing is we can always arrange a 1-to-1 or 2-to-1 or 3-to-1 or whatever you like session if needed. So in the next 2 weeks specifically, maybe the next 3 weeks specifically, I will be very flexible. Anytime you need something, just send me an email and we'll try to set it up. And similarly, the tutors, they might not be as flexible because like you, they have PhDs to do, but we'll arrange something. So don't be shy here, because collaboration is of course part of the learning here, and you might get some different views of how to solve a problem by just doing it together. Even though it's online, it's not really in person. Yeah. So take a look at the data set, and if you have your own data, of course, if you have a data set that is not included here and you have some problem, you need to somehow point me to those data. So either give me a link to a publicly available database where I can download it, or you send me the file zipped, or you give me a Dropbox link or somehow, then such that I can have also the data set that you are working on if you're doing something that is outside of this range. Okay, that's it. I would say go. What else do I need? Submission. There's a submission like for the assignments. Where is it? By the project submission. It's a submission page. Okay, that should do. Let me know if there's something wrong with it. And any link that is wrong or anything, please just drop me an email or somehow let me know, such that it can be corrected. Okay, so go back to the beginning where we started from. That's what you have done. That's what you can do now. So go and do it. Right. Otherwise, I will be back. When will I be back? I don't remember exactly. I haven't made a real plan, but once I see that people have submitted the project, I will bother you again and ask you for a bit of a feedback session where I can question you what you liked about the course, what you didn't like, and what we can do to expand it and make it an enjoyable experience for the future generations. Okay. So I think as much, I don't have anything else to say. Good luck with the work. Come back to me, and hopefully we'll have a possibility to meet in person at some point and celebrate the finalization of that course.